Hi students, welcome to my YouTube channel Lokesh Gupta Chemistry Classes. Today our topic is solutions for JEE Mains 2020. From that today I am going to give solutions for some basic concepts of chemistry, that is stoichiometry chapter questions only. Stoichiometry chapter questions only. Now first question. Among the following statements, that which was not proposed by Dalton's was. See, this was corner question. Very few students only answered this one. Most of the students neglected theory part at the beginning of present at the beginning of the stoichiometry. According to Dalton's atomic theory, matter consists of large number of smallest indivisible particle called atoms. Next, elements consists of atoms of same type. In that element, for all the atoms, properties like mass, everything same. But compounds consists of atoms of different types, atoms of different elements. Next, in the chemical reaction, atoms reorganization only takes place. Total number of atoms of various elements in the reactant side should be equal to number of atoms on the right hand side also. So these are the important postulates. Here these postulates, first statement, second statement and fourth statement are those only. Now what is the third statement? When gases combine or reproduce in a chemical reaction, they do so in a simple ratio by volume, provided all gases are at same temperature and pressure. See, it is the Gay-Lussac's law of combining volume statement. It is the statement of Gay-Lussac's law of combining volumes. So which statement not proposed by Dalton? Third statement. So it is the answer. Next, come to the second question. The redox reaction among the following is. Redox reaction among the following. Redox reaction means oxidation reduction reaction. In a reaction, if same or different elements undergoes oxidation and reduction, that is called redox reaction. Now see, combination of nitrogen with dioxin at 2000 Kelvin temperature. See, at 2000 Kelvin temperature, nitrogen gas combines with oxygen gas to form nitric oxide gas. Nitric oxide. N2. In N2, what is the oxidation number? 0. For elements at oxidation number 0 now, in the elementary state. In O2 also for oxygen, oxidation number 0. In nitric oxide, now oxygen minus 2 oxidation number. Now nitrogen plus 2. Sum of the oxidation numbers of all the atoms in the molecule should be equal to charge, charge 0. So now nitrogen 0 to plus 2, oxidation number increased. So nitrogen undergoing oxidation. Oxygen 0 to minus 2, oxidation number decreased. So oxygen undergoing reduction. So it comes under redox reaction. So our answer is first option only. Let me explain the remaining options also. Reaction of COH2O taking 6Cl3 with AgNO3. Now here what happens? From this solution, Cl minus ion combines with Ag plus ion. Now AgCl white precipitate will be formed. In this reaction, chlorine oxidation number, silver oxidation number not changed. No element oxidation number changed. So it is not a redox reaction. Formation of O3 from the atmospheric oxygen. See, 3O2 in the presence of UV light, it will convert it to ozone. See, O2, O3 both comes under elementary state only. For oxygen in their compounds minus 2, minus 1, minus 1 by 2, different oxidation numbers possible. But in the elementary state, 0 only. This one element, this one also element. So Here also no one oxidize reduce. So it is not redox reaction. Reaction between H2SO4 and NaOH. It is neutralization reaction, not the redox reaction. So these are the two questions. Let me write the third. Come to the third and fourth question. Here, two questions given on the concentration terms. ppm, parts per million. 9th afternoon, 8th morning. Two questions given based on the ppm. What is ppm? Parts per million. What is the definition? Number of parts by weight of solute present in 1 million parts by weight of the solution. 1 million means how much? 10 to the power 6. 10 to the power 6. Or you can define it as weight of solute in grams present in 1 million grams of the solution. In 1 million grams of the solution. For example, urea concentration in the municipal tap water is 6 ppm. Means what? 6 grams of urea present in 1 million grams of the municipal tap water. 1 million grams means 10 to the power 6 grams. That is equal to 1000 kgs. So first you have to know that definition. Now come to the questions. Third question. 10.3 milligrams of O2 is dissolved into a liter of seawater of density 1.03 grams per milliliter. The concentration of O2 in ppm is, so what we have to calculate? Concentration of oxygen in ppm. So what we have to know? In 1 million grams of seawater, how many grams of O2 is present? That number of grams of O2 in 1 million grams of seawater is the concentration of O2 in ppm. Now see, first they given density of the seawater 1.03 grams per milliliter. Now what the information they given? 10.3 milligrams of O2 is dissolved into the 1 liter of seawater. First calculate the weight of 1 liter means 1000 ml of seawater. Density equal to mass by volume. Now mass equal to density into volume. Density 1.03 grams into volume 1000. So this is equal to 1030 grams is the weight of 1 liter of seawater. See what they informed? They informed that 1 liter means 1030 grams of seawater versus 10.3 milligrams of O2. So this is equal to 10.3 into 10 to the power minus 3 grams of O2. This information they given. Now what we have to calculate? In 1 million grams of seawater, that is 10 to the power 6 grams of seawater, how much O2 is present? Now simplify it. This into this by this. This is 10 grams. So 10 grams of O2 is present in 1 million grams of seawater. So what is the concentration of O2 in the seawater? 10 ppm, 10 parts per million. This problem over. Now come to the fourth problem. Ferrous sulfate heptahydrate, FeSO4 7H2O, is used to fortify the food with iron. Means food like here given wheat, foods like wheat to enrich those with iron. What we are using? Ferrous sulfate heptahydrate. Means to enrich that food item with iron, we are adding iron in the form of ferrous sulfate heptahydrate. Okay. The amount of the salt required to achieve the 10 ppm of iron, 10 ppm of iron in 100 kgs of wheat. 100 kgs of wheat. First, calculate the gram formula weight of ferrous sulfate heptahydrate. Formula weight means molecular weight only, but ionic compounds, for ionic compounds better to use the term formula weight, not molecular weight. Iron atomic weight 55.85. If you add all these, gram formula weight is this much. gram formula weight is this much. See, in each molecular formula, one iron is there na? So in 1 gram molecular weight of ferrous sulfate heptahydrate, that is 277.85 grams of FeSO47H2O, 1 gram atomic weight of iron, 55.85 grams of iron will be present. First, what they said, 100 kgs of wheat has to possess 10 ppm of iron. First 10 ppm, 10 parts per million, means in 1 million grams of wheat, 10 grams iron to be present. In 1 million grams of the wheat, 10 grams of iron to be present. It is the iron concentration. Now, how much wheat we taken? 100 kgs. 100 kgs means 100 into 1000. 10 to the power 5 kgs of wheat. Now, this has to possess how many grams of iron? Now, 1 gram of iron. So, if 100 kgs of wheat possess 1 gram of iron, then also in that iron concentration is 10 ppm. So, this much weight of wheat to be has to possess 1 gram of iron to maintain 10 ppm concentration. Now, that iron to be added in the form of ferrous sulfate heptahydrate. Just now what I said, 55.85 grams of iron presenting 1 gram formula weight of ferrous sulfate heptahydrate. Now, 1 gram of iron will be present in how much weight of heptahydrate? This much weight, 4.98 grams. It is the answer. What is the given answer? They given 4.95 to 4.99. They given range. Why? Because lot of calculations involved. So that's why they given the range. So 4.95, 4.96, 4.97, 4.98, 4.99. Whatever you answer, you mark. All are correct. Next, come to the next question. Let me rub the board. Fifth question. NaClO3 is used even in the spacecrafts to produce O2 in the daily consumption of pure O2 by a person is 492 liters at 1 atmosphere and 300 Kelvin. So, for a person, per 1 day, 492 liters of O2 at 1 atmosphere and 300 Kelvin temperature is required. That is per one person per 1 day. Next, how much amount of NaClO3 in grams is required to produce O2 for daily consumption of a person at 1 atmosphere at 300 Kelvin? It is the question. Now, preparation of O2 from NaClO3 also given. See, for 1 day, that person wants 492 liters of oxygen gas at this temperature and pressure. To prepare that O2, how many grams of NaClO3 is required per 1 day? It is the question. Now see, from this given reaction, what we know, from 1 mole of NaClO3, you can prepare 1 mole of O2. So if you want 1 mole of O2, to prepare that 1 mole of NaClO3 is required. 1 mole of NaClO3. That equation they only given. First, here per 1 day, that person consuming this much volume of oxygen gas, first you find the number of moles of that oxygen gas. Temperature, pressure, volume given. Now how to find the number of moles? Ideal gas equation. PV equal to nRT. Now N equal to PV by RT. Now for this much volume of oxygen, number of moles, pressure 1 atmosphere into volume 492 liters by temperature by R value 0.082. They only given that value by temperature 300 Kelvin. So if you simplify that one, you will get to 20 moles. So that person per 1 day, he want 492 liters of oxygen gas at these conditions now. That is equal to 20 liters of oxygen gas. Now see, they only given from this equation what we know. To prepare 1 mole of O2, 1 mole of NaClO3 is required. To prepare 1 mole of O2, 1 mole of NaClO3. 1 mole of NaClO3 equal to 1 gram molecular weight. 23 plus 35.5 plus 16 is 48. This equal to this much. So, to prepare 1 mole of O2 gas, 106.5 grams of NaClO3 to be reacted with iron, then you will get 1 mole of oxygen gas. Now, for that person per 1 day, this much volume means 20 moles of oxygen gas required. Now, to prepare 20 moles of oxygen gas, how many grams of NaClO3 required? 106.5 into 20 by 1. So this is equal to 2130 grams. So it is the answer. 2130 grams of NaClO3 to be reacted with iron to prepare the oxygen gas which is sufficient per one person per 1 day. So this problem over. Next, come to the sixth problem. The molarity of HNO3 in a sample which has density 1.4 gram per milliliter and mass percentage of 63% is molarity. Molarity we have to calculate. They given density and mass percentage or weight percentage. Molarity definition: number of moles of solute present in 1 liter of the solution. Now, if they give the mass percentage and density, there is one direct shortcut formula. Molarity equal to mass percentage into density into 10 by gram molecular weight. If they give weight by volume percentage, then what is the direct formula for molarity? Weight by volume percentage into 10 by gram molecular weight of the solute. Here they given the mass percentage and density now. So apply this formula. Mass percentage 63 into density 1.4 gram per milliliter. In this formula we have to substitute the density in gram per milliliter. They given that only into 10 by molecular weight of nitric acid 63. If you simplify it, you will get 14 molar. So answer is 14 molar. Next, come to the seventh question, last question. 5 grams of zinc is treated with an excess amount of dilute hydrochloric acid and excess of dilute NaOH. This one acid, this one base. The ratio of the volume of hydrogen gas evolved in these two reactions is, now see, here zinc is amphoteric metal, means what? Zinc metal oxide, zinc oxide is amphoteric, na? So that's why we can say it is amphoteric metal. Amphoteric metals can displace hydrogen gas both from acids and from bases also. Now zinc, it reacts with 2 moles of HCl and forms zinc chloride and 1 mole of hydrogen gas. So in the reaction with the dilute HCl, from 1 mole of zinc, you will get 1 mole of hydrogen gas. Next, zinc with alkali, zinc on reaction with NaOH aqueous solution, sodium zincate and hydrogen gas. Here also, from 1 mole of zinc, you will get 1 mole of hydrogen gas. So to answer this problem, you have to know these two reactions. See, in both the cases, from 1 mole of zinc, we are getting 1 mole of hydrogen gas only. So when equal weights of zinc reacts in two cases, then equal number of moles of hydrogen will be formed. Here in both the cases, in the reaction with HCl and in the reaction with NaOH, in both the cases we take in the same weight, 5 grams only. Na? So when equal weights of zinc reacts with excess of dilute hydrochloric acid, excess of NaOH, then equal number of moles of hydrogen gas will be liberated. If number of moles are equal, then under similar conditions of temperature and pressure, their volumes also equal. Now volumes equal, na? Now what will be the ratio? 1:1. So it is the answer. So totally 7 questions given in the January spell out of 6 papers. See, out of 7 questions, 2 questions from ppm concentration term. 1 question, this molarity. So totally 3 questions given on the concentration. Next one question, this and this, these 2 questions comes under stoichiometry calculations. One question, Dalton's atomic theory, and one other question given. So they focused on the concentration terms, stoichiometry calculations. So while preparing, so you to focus on those topics compulsory. It doesn't mean that we can neglect the other chapter, other subtopics. Other subtopics also we have to highlight. Along with that, we have to focus on this. Redox reaction also given. So this is, students. If you like my video, please subscribe my channel and click on the bell icon. Click on the bell icon to get all my notifications. Students, for this also I am giving the assignment. All of you solve that assignment. Next, our video will be on the thermodynamics. Bye, students.